I am Mr. Tarou. Okay, I'm going to do 3 examples involving triangles that require the use of law of sine or cosine. And, these are written on the chalkboard, so I don't want to write out a whole word problem, but I'm going to give you some setups that you might recognize as you read the word problems in your trig or pre-calculus book that involve some applications. So, for our first example, let's say that we have something leaning, like a tree, a pole, a leaning tower of Pisa, and we want to find out the length of that item. So we have something leaning, and whatever it is, and we'd like to know how long that is. So we'll call this, I don't know, A. And you're able to actually go up to it, touch it, take some measurements, and then from those measurements estimate or calculate actually, the length of that object. So you come up to it and you put a protractor on it or some kind of instrument that allows you to measure the angle of that incline, because it's not plumb or square. And that incline, let's just say, comes out to be 7 degrees. So from there, you come out and you walk a certain length or measure out a certain length, and let's just say that that comes out to be 30 feet, single mark is for feet, and you take your tool that you're using to measure these angles with, and the incline or the degrees from this point up to the top of this item that you're interested in measuring comes out to be, try and get my lines a little straight here, comes out to be 68 degrees. Now, from just those measurements, we would like to find the height or the length of this item. Well, what do we have? Not enough to just go, it's 50 feet. So, and we don't actually have any measurements, enough measurements in the triangle to actually calculate that at this length at this point. But if the ground is level, and from that ground, and we have measured a perpendicular line or an angle from perpendicular of 7 degrees, then if this again is now perpendicular, then this is 90 degrees, and that 90 degrees is made up of 2 separate angles. One being 7 degrees that you're able to measure, or of course if you can measure 7 degrees, you could probably measure this degree, but it's a textbook, right? That's what was given. So if this is 90, this is 7, then this has to be 83 degrees. And we have either law of sine or cosine at our disposal to try and solve this problem. Well, don't forget, to use law of cosine, you have to have 2 sides and an included angle. And for law of sine, you need to have a matching pair of opposite side and angles set up. So, since we know that this is, well, do we have enough? Let's see here. Well, we don't. We don't know 2 sides, and we don't have an included angle. We have 83 degrees, and we don't know its opposing side. We have 68 degrees, and we don't know the length of that side. That's what the problem is about. And now we have 30 feet. That's the only side measurement that we have. So to be able to use that 30 feet and to be able to use law of sine to try and figure this out, again, law of cosine needs 2 sides and an included angle, and we only know 1 side, so there's no way for us to set up law of cosine for this problem. We need to know the opposing angle, and of course, now that we have 2 angles that are inside the triangle, we can find the outside angle, or the third angle, up here, and it's going to be 180 minus 68 minus the 83. Well, what is that? Let's see here. We've got 80 and 60 makes 140. Now we have 143. And now we have 151, right? So 180 minus 151 is going to be 29 degrees. Okay, so now we've got that side angle pairing that we need to be able to set up the law of sine. So we have 30 over the sine of 29 degrees is equal to, and we're looking for this length of A, and so that's going to be A over the sine of 68. And we want to get a alone, so we know that length, right? And that means we want to undo this division of the sine of 68. So we're going to multiply both sides by the sine of 68 and get 30 times the sine of 68 degrees over the sine of 29 degrees. And that's equal to A. And because I can't do that off the top of my head, that's going to be 57.4 feet, or units long. And just double check, make sure I got my numbers right here. Bam, there you go. So, we had a leaning object, tree, tower, pole, leaning tower, Pisa, whatever. We have an angle of incline, and we have a length that we measured away from the base of that object of 30 feet. We were also given a 68-degree angle from this point up to the top of our item, and from that information we were able to figure out what the length of that was through the law of sine. So, bam! There you go. Let's do another example. So we're going to do another measurement of an item here. But this time we're going to be able to have less contact with whatever that item is that we're measuring, that vertical distance. So there's some object here. Maybe it's a mountain, maybe it's a tree. I don't know why you couldn't walk up to a tree and start taking some measurements like the previous problem, but there's some item here that we want to measure the height of, but yet we can't make any physical contact with that item to take any measurements. You know, like if it was a mountain, you can't dig your way to the base of the mountain and measure straight up or something like that. Okay, so this item we want the height of. So you're going to come out here, just at some random point, and you're going to look up at it, and you're going to take a measurement, and that angle of incline that you're looking at is 42 degrees. And that's the only measurement you're able to take now, because you can't get to the base and do any kind of leaning angles, whatever. Okay, so you step back some distance, and we're going to step back 100 feet and take another measurement. And back 100 feet, of course you're farther back so you're not having to look so sharply up, you take another angle measurement, and that comes out to be 34 degrees. Now from just those, I guess, 3 measurements, angle of incline, back 100 feet, another angle of incline, we're supposed to be able to figure out the height of that object. Are you serious? I mean, it seems so obtuse or so sort of just out there. How are we going to find that measurement of x? Well, it's going to take some work, I'll tell you that. Okay, well, let's see. If this is 42 degrees, then we know that this angle in here is equal to, well, there are 2 angles forming a straight line, so they're supplementary angles or a linear pair. And 180 minus 42, 180 minus 42, now it's 140. Now it's 138 degrees. So the first angle I found is that one that's adjacent to the first angle of incline measurement of 142 degrees, and we get 138 degrees. Now what I'm trying to do is, we have this one obtuse triangle. I'm trying to fill in the parts enough to where I can actually find some more measurements. So if this is 42, this is 138 degrees. Now I've got this triangle who, again, only has 3 angles, and now we know 2 of them. The 34 degrees we took a physical measurement of, and the 138 based off the 42 degrees. So this angle up here is 180 minus 34 minus 138. Well, what do we have here? We got 138, now it's 168, and now it's 172. So 180 minus 172 is 8 degrees. And just because I'm paranoid because I don't want to make a mistake on another video, yes, 8 degrees. Okay, so we found this angle of 138, we found this angle of 8 degrees. Now what can we find? We're not going to again find x directly, we don't have enough information yet, but we have this side of 100, and we know the angle that's opposite that 100 feet Yes, of 8 degrees. So if you have that side and angle pairing, you have enough information to set up the law of sine. Now, there are ambiguous cases for law of sine where you might have more than one possible triangle from the information given, but we have an angle, side, angle, and that's one of the congruency theorems or similarity theorems from geometry. So when we get our answer from our calculator, that's going to be the one valid answer that there is, so we'll be safe. Okay, so 100 over the sine of 8 degrees equals, well, what we're going to find is this side right here that's opposite 34, and let's call that A. I don't really necessarily care about the length of A for my final answer, but I need that value to build up enough information to find out what x is. So we have A over the sine of 34. Okay, well, it's A divided by the sine of 34. I want A alone. I want to undo that division. So I'm going to multiply both sides by the sine of 34. Equals A. And get that typed into your calculator correctly, and you will get the answer of 401.8 feet. Okay. Now, I'm going to just, I'm rounding these values off to the nearest tenths just for convenience and what comes out of the calculator. If you're doing a science class and you're talking about significant digits, my measurement here of 100 feet and there's no decimal at the end of that implies that I've rounded off my measurement, my actual physical measurement, to the nearest ones place or whole value. And you cannot really have a calculated value that represents a measurement more accurate than your real physical measurement. So you could argue that I really need to round this off to 402 feet, round off the nearest ones place like I did the 100 here, or as it was presented. But I'm leaving it at 401.8 just as a math exercise. Your science teacher may have another opinion about that, okay, and physics teacher and such. So A comes out to be 401.8. And now we finally have enough information to find out the value of x, the height of that object, whatever it is in your word problem that you're reading to, that's asked you to do this problem, this application. And what are we looking at here? We're looking at a right triangle. And when you have a right triangle, I guess I should have said, we're going to be measuring vertically or perpendicularly from the base. And when you have a right triangle, you can just go back to SOHCAHTOA. Sine's opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. So, from the 42, we want the opposite side from 42, and we have the hypotenuse. Well, when you want the opposite and you have the hypotenuse, that is going to require the sine function. So, the sine of 42 degrees is equal to x over 401.8. And again, we want to undo that division, that fraction bar, by multiplying both sides by 401.8. And x comes out to be 268.9 units. I've already marked off feet, so bam! There you go. That's the height of this item that we were able to calculate without ever physically approaching it, touching it, taking any angle measures off of it. We just stood out here, we looked up, we stepped back, we looked up, and that was enough information to find the height of whatever that item may be. Mountain, tree, whatever, okay? That your application's actually about. Bang! All right, one more example. Alrighty then. Next page of notes. You travel east 30 miles. You then head west, or excuse me, that's not what I have written. You then head south 25 degrees east for 17 miles. Okay, the first question I want to ask, based on that information, is how far are you from where you started? A pretty basic question. Well, we need to take these words and actually make some kind of diagram out of them. So, you travel east 30 miles. From where? I don't know. Here. So we travel east. And we do that for 30 miles. We then travel, so we're going to stop here, if you will. Look at our compass, and we're going to turn south 25 degrees east. Well, north, south, east, west. So from due south, we are going to travel or turn 25 degrees east. So from south, we're going to favor the eastern direction by 25 degrees. I think I drew that a little bit too small there, but that's that little part to the right, of the vertical line. So we're to the right of south or east of south. And we travel 17 miles. So my line's a little bit too long here. Maybe we'll just make that longer. Okay, so 30 miles east, 17 miles south, 25 degrees east. And we want to know, how far are we from how far are we from where we started? So that's what we're looking for. Well, do we have enough information to figure that out? Well, since the original measurement was directly east and north-south is perpendicular to that, this could be a worse problem, or a more difficult problem, but traveling exactly east like this doesn't make it too terribly difficult. If this is east and this is a north-south line, then this part of the diagram is 90 degrees. And 90 degrees and the additional 25 degrees from south 25 east, well, those add up to what? 90 and 25 is 115 degrees. Okay, well, do you see what we have here? We have two sides and an included angle. So you might be thinking, hey, you say we're doing law of sine and cosine, and I never did write the formulas up, did I? Sorry about that. So, how far are we from where we started? Well, with two sides and an included angle, that's law of cosine. So x squared, the side that we don't know, is equal to the other two sides, the other two sides squared and added together, minus 2 times those other two sides, times the cosine of the included angle. And I should have reminded you this on the previous two examples, but if you're in pre-calc and trig, you've been bouncing your calculators back and forth between degrees and radians. Make sure you're in degree mode, otherwise you're going to get all these answers incorrect. X squared is equal to, when you get all this typed into the calculator correctly, 1620.07, and you square root both sides of this equation, and we get x is equal to 40.25 miles. Or if you don't want a calculated measurement, more accurate than your physical measurements, approximately 40 miles from where you started. Good. So that wasn't too bad. Now I have another question. If you remember, you were here now, right? Because you traveled from home or port or whatever. And I want the bearing from here to get you back home. Okay? What direction must we take to get from this point back? I don't want to go back in the same path. I want to go straight there. I only want to travel 40 miles, not 47 miles. Well, if I want a bearing north-south line, if I want a bearing from there back home, well, let's see. This part that I definitely should have drawn a little bit bigger. Let me get the 17 out of the way. That little piece right there, how many degrees is that? Well, every time you draw a north-south line, when you're talking about bearings or directions, like when you're reading a compass, every time you draw a north-south line, those are all parallel, right? It's north-south. So we have two parallel lines being intersected by a transversal. How long has it been since you heard those words, right? When you have alternate interior angles, those alternate interior angles are equal. So this little piece here that I've now drawn is, or angle, is also 25 degrees. So if I can find this part of the angle, then I can add it with 25 and be able to say, well, to get back home, my bearing is north blank, and then we're going to find out how many degrees there are to the west. So what do we have? Well, I don't need this x in here anymore because I know what the measurement is. It's 40.25. How are we going to use that to now find this measurement in here of angle y? Well, I've got this side is 30, and the opposing angle is what I'm looking for. And I have this 40.25 now, and I know its opposing angle. And again, anytime you have this setup where you know an angle and its opposite side, then you have the ability to set up the law of sine. And don't forget, do not try and find an angle opposite the largest side with the law of sine. If that angle ends up being obtuse, you will not be able to get the answer from the law of sine because your calculator will not be able to give you that answer. Inverse sine with your calculator only gives you answers between negative 90 and positive 90. Okay, so a little cautionary note there. Let's finish this problem and call it a day. So, we have 40.25 over the sine of 115 degrees equals 30 over the sine of y. I hope I used the same setup as I did in my notes here so I can come up with the answer for you. Yeah, okay. So our variable's in the denominator. We cannot solve for a variable when it's in the denominator. So I'm going to cross multiply. There's only one fraction on each side. So we're going to have 40.25 times the sine of y equals 30 times the sine of 115. Sine of y, we want to get the 40.25 away, so we divide both sides by 40.25 and get sine of y is 30 times the sine of 115 degrees over 40.25. That comes out to be 0.676. And we have the sine of y equals that 0.676. And y is equal to the inverse sine of 0.676. And that comes out to be 42.5 degrees. That is not your answer. That is this little tiny piece in here. Well, it's not so tiny, but this is y. Part of the bearing value, right? So we're going to head to get from here back home. It's going to be north 25 plus 42.5. So it's going to be north 42 and 20 makes 62. Another 5 makes 67. So it's north 67.5 degrees west. Let me just double check that. Close enough. I'm Mr. True. Bam! Go do your homework. Thank you for watching. I do appreciate it very, very much.